So first, key thing that we're going to look at is what is the standard position of an angle. So you can turn to page 468 and maybe put these definitions on the side. But we're going to start by playing a game that I made up called standard position for an angle or not standard position for an angle. Sounds like a very exciting game. It will be. And the way that this game works is I draw an angle. That angle is in standard position. Then I draw another angle on this side, and that angle is not in standard position. So we do this a couple of times. Meanwhile, you are trying to determine, based on all the pictures, what makes something in standard position and what makes it not in standard position. Okay? So there's example one right here. Make it a little bit smaller now. This one is not. So I'm going to put on this side, yes. And this side, no. All right, here's our next one. This one is no. How about this one? Oh, whoa. This one, yes. That one's standard position, that one's no. How about whoa. That one is yes. Okay, you don't have to write these down. This is just that one, oh, it's already ready. That one is no. What else could I do? How about this one? That one is no. Do you need more examples? Or do you think you've got an idea for when something is in standard position and when an angle is not in standard position? You ready? Yeah, okay. So what would you describe an angle in standard position then? Okay. So all three of these started on the positive x-axis and then go to the angle. Okay? An angle in standard position starts on the positive x-axis. And then it goes to the angle. And it doesn't matter which direction it goes. In fact, if I would guess, this angle looks like it's around 220 degrees. And when you go in the counterclockwise direction, it's positive. This one looks like it might be negative 220 degrees. So when it's going in a clockwise direction, we call that angle negative. And it can go around more than once. This would be like 360, 720. That one looks like about 750 degrees. So there's definition number one. That's important. Okay? Definition number two. That's important. Something from last year. do you remember, very important definition, what a reference angle is? Okay? Now we're not going to play, I know it's very exciting, the reference angle, not reference angle game. We could play that. Instead, what we're going to look at is I'm going to draw an angle, say 30 degrees, and then I'm going to tell you what the reference angle is. And then you have to tell me how you figure that out. So if I give you 30 degrees, the reference angle is, and this is how we would write it if this angle is theta, then we would write theta with a little r to show the reference angle. And here the reference angle would be 30 degrees. If I drew an angle in quadrant 2, say this angle was 120 degrees, then the reference angle would be 60 degrees. If I drew something in quadrant 3, that looks like 260 degrees. The reference angle would be 80 degrees. And finally, if I drew something in quadrant 4, say 340 degrees, then the reference angle would be 20 degrees. So then the question is, if those are the answers, what is the definition? Oh, we could make a game. We could call the game, those are the answers, what are the definitions? How do we find a reference angle? What's that? It's quadrant 1. So we notice, yes, that all of the reference angles are angles in quadrant 1. Okay? But how do I, so if the angle's in quadrant 1, it's going to be the same? Okay? Seems reasonable. That seems to match here. But how does that, doesn't really help me find this one. Mm-hmm. From the angle. Okay, so this one's 30 degrees right here. So 90 subtract 30 would give me 60.
Oh, wait. Yeah, no, I don't know.
Okay, all right. Mm-hmm. So if I added one, okay, let's say 170 degrees. How are we going to figure out the reference angle? It's how much? It's 10 degrees. Okay, so how did you figure that out? You just ignore the 7? And then you get 10? Is that? Well, it doesn't quite work, but it's the right answer. 180 subtract 170 gives me 10. Did that work for this one? Right, 180 minus 120 gives me 60. Does it work for this one? 180 minus 30 is no. So it works for quadrant 2, but it's not a definition yet. Because if you've got a formula that only works sometimes, you're not really saying what a reference angle is. If we figure out what a reference angle is, then we're going to be able to make formulas that make sense. So then we have to figure out what's in common in all of these ones here, so that if I give you 225 degrees, you can tell me the reference angle is what? And this one's not 180 minus. 180 plus 225, so it's 405. 225 minus 180, so you get 45 degrees. That is the reference angle. So now we have to figure out, well, how is what we found the 45 degrees here similar to what we find the 10 degrees there? Similar to, if we go down to quadrant 4, similar to how we can figure out the 20 degrees. What is the definition of a reference angle? One way that might help us is if instead of just writing down the reference angles, we actually label where that 30 degrees is on the graph. Okay, here, 30 degrees is this one right there. Okay, where do I have 60 degrees on the diagram? Right here. Okay, where do I have 10 degrees on this diagram? Right there. Where do I have 45 degrees on this diagram? There we go. Okay. Where's the 80 degrees on this one? And finally, where's the 20 degrees on this one? Right there. So what do they have in common? How could we describe each of those green lines with one definition? The angle from the nearest x-axis, right, to where the angle ended. Okay, so I'm going to give you some a reference angle is the, and it's always positive angle from, and we say where an angle ends, we call it the terminal arm. Terminal meaning where it ends. I forgot the word angle. Here we go. A reference angle is the positive angle from the terminal arm to the nearest x-axis. And it's always to the nearest x-axis. And I specifically down here drew 260 degrees because sometimes you're going to be like, oh, it's just so much closer to go to the y-axis. Why don't I just make it 10 this time? No, it's always to the nearest x-axis. So it has to go all the way back here. What do you think the reference angle would be for 270 degrees? It's 90 either way. So the reference is 90 degrees. To the nearest x-axis, it doesn't matter which one you go to, that would have a reference angle of 90 degrees. What about if you had 180 degrees? Then your reference angle would be 0. Oh, I didn't do any negative ones. What happens if you went negative 30 degrees? Your reference angle would be 30 degrees. Because then you'd figure out, well, how far would it get to go back? It would just be 30 degrees. So reference angle is always positive, and it always goes back to the nearest x-axis. Now, why did you learn reference angles? Okay. Here's something from grade 11. Should we pick one that you know? How about 30 degrees? So if I pick 30 degrees in quadrant 1, and then I pick the same reference angle in quadrant 2, this would be 150 degrees. And if I pick the same reference angle in quadrant 3, this would be 210 degrees. And finally, the same reference angle in quadrant 4 would be 330 degrees. Can you notice that each of these reference angles all the way through is 30 degrees. So let's see if you can remember one of your memorized values from grade 11. What is sine of 30 degrees? Oh, lots of smiles like I have no idea. I've completely forgotten. You remember? It is 1/2. How many people remembered it was a half? Couple?
That was mostly from physics.
Mostly from physics, so the math really didn't help last year. Great. Okay, so sine of 30 degrees is 1/2. And what that means, you know from way back, like grade 10 SOHCAHTOA, that means sine is opposite over hypotenuse. If you decided to draw a straight line down here and make a right angle triangle, and you took out your ruler and measured the opposite side, say it was 2, you would know your hypotenuse would be 4, because sine of 30 degrees, 2 divided by 4 is 1/2. If you drew a longer one here at 3, then the other side would be 6. And if you drew the one where it was 1, it would be 1 and 2. The ratio between the opposite side and the hypotenuse will always be 1/2. Okay? Now, when I have a reference angle of 30 degrees in quadrant 2, can you see if I draw a line straight down and this was 2, it'd make exactly the same triangle? Right? This would have to be 4. And so when we go to our calculator, we find out that sine of 150 degrees is also 1/2. And the reason for that is based on the reference angle. And for the same reason, if we go to 210 degrees and we make a triangle and we made this 2, this would be 4 again. And when you type in sine of 210 degrees, although if you type that into your calculator, you don't quite get 1/2. You get -1/2. Well, the triangle's the same. Part of the reason it's negative is now your opposite side is going down. That's part of the reason that it's negative. We're going to see some other reasons why it's negative later on in this class. Okay? But it's still the same triangle, so we still get the 1/2. Do you guys remember also learning the cast rule in grade 11? So according to the cast rule, all of them are positive in quadrant 1. Sine is positive in quadrant 2. That's why we got a 1/2 here. Tan is positive in quadrant 3, so sine would be negative. Cosine's positive in quadrant 4, so sine would be negative in quadrant 4 again. And sure enough, if you do this in your calculator, you get -1/2 again. So if you know your reference angle, you can find out all the other angles as well that are related to that. That's the powerful thing about reference angles. And again, if I drew this same triangle in quadrant 4, can you see that the y value is negative again? Okay. Cos is positive in quadrant 4. Can you see that the x value is positive? So that's going to be part of it. Okay. This is reference angles. That's our next important definition. One more important definition. Coterminal angles. Okay? 30 degrees is coterminal. You don't have to write this down. We'll get the definition again. Do you like this sort of having to try and figure things out, or are you just like, just tell me the definition already? It's like, okay? 30 degrees is coterminal with 390 degrees. 200 degrees is coterminal with -160 degrees. I'll give you one more example. 1,000 degrees is coterminal with 1,360 degrees. And now we have to see if we can figure out what does it mean when two angles are coterminal. Should I give you another one that's not helpful? Yeah, why not? There we go. 1,111 degrees is coterminal with 3,631 degrees. Yeah, and that shouldn't help you whatsoever, but it's true. Okay, so the first three are somewhat helpful. The last one, not really helpful, but just for fun, there it is. So how can we tell if two things are coterminal? And what does it mean? Okay, now whenever we write an angle, the reason we have standard position is so that when I'm talking about 30 degrees, your mind should go like this. Okay, start on the positive x-axis, end in quadrant 1, there's 30 degrees. It's not, the reason we have a standard position is so that when one person talks about 30 degrees, another person's not like, oh, I'm in quadrant 7. Well, there's no quadrant 7. Yeah, that doesn't make sense, right? So we try to standardize things so that we're talking about the same thing. So there's 30 degrees. And then supposedly that's coterminal with 390. So if someone drew 390, that would look like that. Okay? If I drew 200, what quadrant would that be in? 180, quadrant 3, right? 200. If I drew negative 160, that would be going around this way. That would look like this. I don't want to draw 1,000 right now, but I could, I guess. Ooh, yeah, 1,000 might be good. You ready? It's like, ooh, 720. Maybe? Maybe? Is it like kind of hypnotic there? You like math. Right? Here we go. Okay. There's 1,000. And then 1360 would look like that, I think. What does it mean when they're coterminal? I'm not going to draw 3,631, otherwise you might get hypnotized. What does it mean if things are coterminal? What do you notice about 390 and 30? 200 and negative 160. And even 1,000 and 1360. They have the same reference angle, but 30 degrees is not coterminal with 150. So it's a good, that is something that each of those have in common, but if I do 150, it's not coterminal with 30 degrees, even though they have the same reference angle. The terminal arm is in the same position. In fact, the English language kind of gives it away. Terminal and co, right? Like when we have co in front of words in English, what does that mean? It's sort of like share. Sort of like, you know, there's a co-ed soccer team. I play on a co-ed soccer team. That means both genders are on that. Or you have like cooperate. You operate together. You share something. So the definition of coterminal angles is that two angles are coterminal if they share the same terminal arm. Right? What are other co-words? Coexist. So in the rest of in your textbook, we've written them around. They've got standard position questions. They've shown a couple of standard position questions. They've got here some coterminal, if you like highlighting stuff. I like highlighting stuff. There's the definition in your textbook. They share the same one. So 40 is coterminal with 400, is coterminal with 760. It's also coterminal with negative 320, negative 680. And so there are infinitely many angles that are coterminal with any given angle. Okay, those are our first definitions.